Got to simplify radicals. This can be pretty useful when you're working with more difficult algebraic expressions. So we're going to kind of learn the basics here. This is invisible 2 here. The index is 2. Here the index is 3. This basically tells us the size of the identical factors that we can take out. And we can just start with the number here. So we got to break down 294. And I know that it's 49 times 6. So that means inside 49 is a pair of 7s. So this means that a pair of 7s is coming out, but a 6 is staying on the inside. And then I'll just attack the variables. So now that this guy is reduced, and you can double check this, the square root of 294 is 7 times the square root of 6. You can go ahead and try it, and it will work. You can test it in your calculator, so there's no issue there. We're going to look for a pair of identical factors here. Here we have 2 pair, and if we have 2 pair, then we've taken all 4 of the a's out of the radicand. So now there are none left. Here we take a pair of b's out. There's 1 b left because there's an odd number. Here we have an even number, so we're going to take out all 4, but we will have 2 pairs of it, and that is all. So it looks like my final answer would be C. Over here, if there's an odd index and it's negative, no big deal. We will take out that negative sign. Try to imagine that there's a triple of -1 on the inside there. You can just take out the negative sign. So we got negative. Inside 48 is actually, what is it, 8 times 6, right? So that's 4 times 2. So what is that? That's 16 times 3, right? So 16 times 3, I can take the square root of 16. That's 4, but I am left with the 3. I got nothing. I cannot take any x's out. Oh wait, my bad. I need triples. So there are 2, 2, 3. So there's a triple of 2's. So only 2 and a 6 would be left. Okay, so 2 and a 6. Okay, and again, you can verify the square root of 48 equaling the cube root of 48 equaling 2 cube root 6. Okay, so my brain, I was looking downward and I was thinking square roots, but these are cube roots. Alright, can't take out any x's, can't take out any y's, but you can take out 2 triples of z and you would have none left. So we got negative 2 z squared cube root of 6x, that's it. This guy here, 150. We're taking the square root, so that's 25 times 126. So that would be 5 on the outside, 6 on the inside. And I already know that my answer is B, but I'm going to take out an x. Can I take out an x? Nope, can't. I can take out a pair of z's, but I will have one of those z's left over. Nothing else comes out, and that is my final answer. 1,000 is 10 to the 3rd power, but because it's negative, we're going to take out negative 10. Okay, and now we got a triple of h's with 1 h left, a triple of j's with 1 j left, and we can take out two triples of k with 1 of those left. So that's going to give us this guy right here, C. These guys are pretty simple. There's nothing to do. You're just changing its form. This is very important when you get to calculus. So we look at this and we see that if we're taking a root, that would be the denominator, while raising it to a power is the numerator. So we're just looking for this guy. That's D. Alright, this guy's the same thing. 5m is on the inside, so 5m both are having the same things done to them. So that would be 5 over 2, but because it's 1 over, we know that we need to make that negative. Make sure you keep him in parentheses. That's A. This guy right here, looks like only the 2 is going to have the is going to be squared. So what we've got to do is make sure the square only goes on the A. So 2a squared being raised to the 1/5 power is the only one that makes sense, unless you did it like this. Okay, this is your only other option. Okay, because the 2 is not being squared, but the a is. Okay, so this is just v to the 3/4, but he is a negative exponent because it's a 1 over. Okay. With these guys, you can only combine them if the radicands are similar. These guys have different radicands, but maybe we can change that. We can change this guy right here. We can look for pairs. There's a pair of 3's on the inside of 45 because it's 9 times 5. So take those 3's out and you will get -6 on the outside because they're already -2. And you will have radical 5. Well, that's cool because I have a radical 5. I can combine those to get a -3 radical 5. This one right here, we can reduce it. I don't think I'm going to get a radical 5 though, but I can take out a pair of 2's and I'd be left with 3. So these guys I can combine, this guy I cannot. And so my final answer is going to be this right here, A. Okay, now these guys, these I can combine immediately. That's -3 radical 54. I don't see any radical 54's here. This guy, I'm going to pull out a pair of 2's, and so that would be 6 radical 6. Okay, because 24 is 6 times 4. I can take the square root of 4 as 2. I got a 6 left over. 6 stays, 2 comes out, bam. Alright, now 54, that's going to be 9 times 6, so a pair of 3's will come out. So I'm going to have 6 radical 6 minus 3 radical 9. And then we're going to get radical 6. And then that guy's the same thing. No, wait a minute. We already combined those, so that's it. So we got -3 radical 6. We already combined those two to make this. Alright. Alright, you guys leaving? Alright, have a good day, guys. Could you do me a favor and lower my desk right there? And just hit the number 1 before you leave? Thanks, bud. Okay. This guy, I got a pair of 3's in there. 9 radical 2. I got a pair of 2's in there. That would be 4 radical 5. 3 radical 2. These two will combine to get 12 radical 2 and 4 radical 5. We just did that one. It's going to be 4 radical 3. This guy's going to be -2 radical 3. 27, there's a pair of 9's in there, so that would come out as a 3. 3's already there, so 3 times 3, radical 3. They're all radical 3's. 13, you got 10. Ooh, did I mess up? I probably did. Let's take a 2 out, 4 radical 3. Let's take a 3 out, 3 radical 3. Take a 2 out, radical 3. What am I doing? 13, oh, 13. Okay, so that's addition, subtraction, multiplication, no big deal. Multiply the radicands with the radicands as long as they have the same index. Okay, now all of these will, because they're all square roots, that's the most common. I'm going to get -20. I can multiply the outsides. And then that's going to be radical 5 is 75, I believe. But you're not going to see that answer because that is 25 times 3. So take a 5 out, and I'm going to get -100 radical 3. Okay, distribute. You're going to get radical 50. Distribute again, plus radical 20. You're not going to see that answer because I have to take out the pairs. Okay, and that's it. Where's this guy? 5 radical 2. Oh, you know what? I'm sorry, my bad. He's not in a radical. I was trying to do it too quickly. He just kind of attaches on there. So that is the final answer right there. Alright, this guy has the radical. So this is going to be radical 45 plus radical 10. He's done. There's nothing you can do with this guy. I believe. No. Oh, man, I'm slipping up. I haven't drank enough coffee. It's still early. So here we go. Got 3 radical 5. Inside one, let's see, we got 25 times 6. Okay, so that's this guy. Alright, now we got to do double duty here. So -4 radical 6 Negative 4 radical 6. That's just going to be 2. And that also will be plus 2. Okay, so we get negative 8 radical 6 plus 4. Alright, you could have actually added those two before you distributed. That was another thing you could have done. Alright, and finally for this one, that's going to be negative 5 radical 25, which is just 5, so that's negative 25. This guy right here is going to be negative 5 radical 15. Then the next one is going to be, now this guy, is going to be 4 radical 15. And that guy will be 4 times 3. Because 4 radical 9 is, that's just 3, so 3 times 4 is 12. Okay, so negative 25 plus 12 is negative 13. Add those two, that's going to be a negative radical 15. So that is D.